Hello, I'm Ted Kinsman. I'm a professor of photographic sciences at Rochester Institute of Technology, and today I'm going to be talking about what reflectance transformation imaging is. It's a technique that's often abbreviated as RTI, and I'm going to show some demonstrations of how powerful the technique is first, and then show you how to build one. So reflectance transformation imaging is a really interesting technique. And here I'm showing a shotgun shell, and it's in normal vectors. And I'll speak a little bit about what a normal vector is, how it all works. RTI dates back to around 2001 when Tom Melzbender put the program together and designed this for visualizing the ancient calculator that was discovered way back in the early 1900s. It's now evolved into an open source software and is maintained by the Cultural Heritage Imaging Institute in San Francisco. And they've just rewritten the software. So it's all new and it works really great. That just happened in late October of this past year. And I will be using Relight to put together some files here and show you how cool it is. Artifacts, but in looking at coins, looking at Pokemon cards, looking at baseball cards, as well as looking at rare documents. RTI has really found its home by being able to send exquisite detail from one researcher to another for rare and unique objects that can't be sent through the mail. This is RTI Viewer. There's two programs that have to be used in collaboration to work with RTI files. There's an RTI Builder, which is a new program called Relight, which was just released a few months ago, and this program, which is RTI Viewer. Typically, you're going to photograph an object, whatever you're interested in, and it's going to have this black sphere here. Currently, we've developed some software that can remove this black sphere and put it in the programming, but that's still a little bit in the future. But this black sphere is a calibration sphere, which tells the program what direction the light is from. And in this view, this is the default view, which I can move the light around. And this is pretty cool in itself. When I talk about this program, I'm going to zoom in on just the object of interest, which is this this close-up of this shotgun shell. I'm going to move the little browser here right over the shotgun shell so we can see what the end of the shell looks like. So I can move this view around, and this is a kind of a nice way of looking at the lighting, but it's nothing that you can't do with Photoshop. In that sense, it's not super unique, but it is just a start to this program. So in this sense, what I've done is I've collected 40 images, all at different angles, and I'll talk about that in a little bit, how this image was collected and how you can construct one. But first, let's talk about the power of an RTI system. So in this case, I can move the lighting around, and this program collects these 40 images and then combines them and extrapolates mathematically what this surface is going to look like. It does that by figuring out the direction of the normal vectors. And a normal vector is a vector that's at 90 degrees to a surface. So once that mathematical surface is developed, we can do all sorts of things with it. And this is the power of RTI. We go from this default viewing into a specular enhancement. And now we can see all of these different types of characteristics of the file because we can switch, we can move the diffuse lighting around, and we can bring out different characteristics of the surface that might interest us. And so we can see here that there's a little scratch on the casing. And I can also move this virtual light around now to highlight any of the parts of this object that I am interested in. I can also change the specularity of the object back and forth. It only changes when you release the slider. And I can also change the highlight size. And I can change this spot size. It kind of gets bigger when the number is smaller. And this is a way to see objects on an artifact in exquisite detail. And it's relatively new, only developed around 2001. So that's specular enhancement, and this is typically the mode of operation. And in this particular program, if I want to do a screenshot, I can click on one of these and output a fairly large file of whatever I am looking at. There's also a third view in this particular RTI viewer software, which is a normals visualization. And a normals visualization mathematically tells the direction of the normal vector by giving it a red, blue, or green color. So that's a way of separating out the direction of these surfaces very quickly by looking at the color. And of course, I can't adjust this view at the top here because the normals are unique to the surface. So by changing the lighting, it doesn't affect anything at all. So that's the power of RTI. And this is useful for using a digital transfer of special objects, whether it's an artifact, evidence, or something that you want to show to another researcher to determine if it's maybe the real thing or a fake, or it's been modified, or any of these surfaces that might hold value to them. That's the start. Let's talk a little bit about the process and how you collect a data file and how you build an RTI. So I'm going to jump out of this viewer and go to a little PowerPoint. The way that I collect images is by using a trio lighting dome, and I'll give links somewhere in the back of this PowerPoint to this site. But it automatically collects images. It's I use a rolling shutter, which is very stable, no vibrations in the system at all, and the images are collected in under 2 minutes. So I can program, put an object in there, collect an image, and this is great if you've got 100 objects that you want to collect and automatically put together into RTI files. This is the way to do it. I should note that RTI files can be built by hand by changing the location of the light and going through them one by one, but it's really quick just hitting a button and being like, okay, I'm done. So this is the way to do it. This lighting sphere has 40 lights, and each light turns on in turn, and one picture is taken, the light turns off, the next light turns on, it takes another picture, and as long as you have a fairly quick exposure, you can get through all 40 lights in just a few minutes. You can actually drive it really fast if you want, but I typically don't want to drive it too fast because it does take time for the files to be written to a modern digital camera. So this is a trio lighting sphere, and it's one that I've helped develop, and it's kind of cool. It really simplifies the collection of RTI. Inside the sphere, there's 40 lights, and each light turns on one at a time. Here they are all together. All lights are on, and here's a little clip of them going through their sequencing so you can see how each light turns on and an image is taken. Of course, the lighting sphere is on its side here, and this is just for demonstration. Here's the controller for the RTI. You can set up how long it dwells on each image for, and that's linked to your exposure time. And you can, of course, step it through each individual lighting one at a time, and that's useful for focus as well as exposure settings. So here's how an RTI is actually collected. Your camera is above your object, and it's facing typically straight down on the object. And one light turns on, and of course the light hits the object and it scatters in every direction, and the light hits the camera. So this lighting position allows the software to collect and extract what the normal vectors are for the surface. Once you know the normal vectors for the surface, then you can mathematically enhance the object. And of course, it does this for not only one light, but 40 lights. And so here would be a second lighting position, a third lighting position, and a fourth lighting position as a demonstration. Of course, it has 40 of these as it goes through the program. And in the end, we extract the normals, and they are unique to the surface. So it extracts a normal vector for each pixel of your digital file, which is pretty amazing. So once we've got those normal vectors, then we can mathematically enhance the image, and we can change the specularity, and this helps our eyes be able to detect fine detail in the object we're looking at. So here's a typical setup. We've got a calibration sphere on the top left and our object that we are interested in on the right side. This is just a typical setup picture. I would typically use a smaller calibration sphere and go in a little bit higher resolution for this if I was going to be documenting this. But our current software uses a calibration sphere. Future software will have that calibration sphere built into the file that's unique to the dome for creating an RTI. So if we look at this shotgun shell just by itself, we can realize that each one of these pictures has different detail on the sides. And we're taking all of these pictures and combining them together mathematically to extract unique surface details. So here's all the multiple pictures, or just a few of the ones that were taken for this data set. So here's the relight software. And the first thing I do is I come way over here to the left, and I'm going to pick a new project. I have to go to the JPEG exports file, which the images have to be in that file. I'm going to open that file. And this is pretty much my setup images. I've got the calibration sphere here in the center, my shotgun shell over here on the side. And the first thing I'm going to want to do is tell the program where the calibration sphere is. So I'm going to click on this new sphere. I'm going to zoom in. I can use a mouse to zoom in and really well. I'm going to pick 3 points on the edge of the sphere. So my first one, my second one, and my third one. And if I don't like any of the images, I can select any of these images in the files over here on the side, which represent all of my data files. In this particular set, I have 37 data files. Any one of those will be perfectly fine for helping you select your sphere. Once I have all that done, I have to come up here to the file, and under edit, it says find highlights. So I'm going to click on that. It'll take a few seconds for it to go through all the images and to determine where the highlights are in the file. Once it determines a highlight, it puts a little tiny green X in it. And that green X means the center of the highlight, and it will use that to help generate the mathematical files. Zooming into the sphere in any one of these files shows me that little green X for the highlights. And of course, if I pick a different one, there's my green X, and it should be exactly in the center of that reflection from that particular light. Once all of that is done, I come up to the top bar here, which says Export RTI, and I get this relight export screen. There's some buttons here I have to make sure I select. And the first is it has to be an RTI format. There's a lot of other formats, and there's many other things you can do with this program, but I'm just going to introduce it with RTI, and we're going to pick one of the most common texture maps, which is a hemispherical harmonics texture map. And once that's picked, I'm ready to begin. Now, this would export a really huge file. I'm not really interested in all of this extra space, so I'm going to use the crop tool to come in and look at just the part of the image that I'm interested in, which in this case is the end of that 12 gauge shotgun shell. Once I've cropped the image, I'm going to come down here and say OK, and click Build. And I have to give it a name, in this case, 12 gauge test. And it's going to put it in my folder that holds the images, in this case, a folder that's called Shotgun Shell 3. And I save it there. And it's going to build this RTI file, put it in that directory. And it'll take a few minutes depending on how fast your computer is. In this case, I'm just going to let it run real time. And we see that it builds this RTI file from the relight program fairly quickly. And there it is. There it's done. So at this point, we're done with relight program, and we are going to switch over to our next program, which is RTI viewer, and we'll be able to view what goes on. So I'm going to come here to my input. Going to open the RTI file to be able to see what is going on with it. And here's the file that we started the video with. It shows that shotgun shell, and we can move our lights around to show that from different angles. We can export any picture we want, and we can zoom in on any part of the image that we're interested in. Maybe we're interested in one of those little stars there. Maybe that star. And we can zoom in and now play around with that image with the lighting, with the mathematical generated surface here with the specular highlights. We can change those highlights with the diffuse color. This applies the color from the data files, or we can turn the color off. It's always nice to leave it on a little bit. And then the specularity, we can turn that specularity off, move it around, or we can change that specularity way up very high. And now we can change that highlight size to a fairly small point source. And we can look at all of these different details on that particular specimen. And of course, lastly, we have that normals visualization, which shows each of the normal vectors characterized as a red, green, and blue pixel, depending on which part of that sphere, the giant hemisphere that they're pointing at. I can't change this in this little pointer because this is a mathematical representation of that surface with the colors applied. So it gives us an idea of what that surface represents. I should say that the normals visualization is a really good way to tell if your RTI file is good or not, because if it's all messed up, the colors won't be very different at all. So this is a pretty good representation, clearly shows that there are big differences in the normal vectors, and it's able to pull that surface out mathematically. So that's how to view one with the RTI viewer. What I am going to do now is show some examples of various objects under RTI viewer. And so here's a golden staff, which has a lot of surface detail. And of course, we can move the light source around our virtual light source, as well as change it into a specular enhancement. And most of the time in specular enhancement, you really want to keep the color of the object if you can. And I'm going to probably decrease the highlight size here. I'm also going to zoom in on some of the structures of this golden object. The stem here of the cane has a lot of ornate work with it. And we can see that as we move this around, we really get a very good idea of what this object is. We can see the structure, we can zoom in, we can see all of the little scratches and nicks that are on this object, as well as the surface condition if we were interested in buying this object. The last way to look at this is to see the normals visualization, which is a fantastic way of looking at the normal vectors and seeing how it relates to this object. Really gives us a great idea of what direction the surface goes in. Do these little dents poke in or do they poke out? We can tell that from the normal vectors. Here's a classic example of a collectible coin, and in this case it's a Liberty head silver dollar, and it's from early 1900s. And we can look at this object as if we were a collector and we wanted to establish the condition of it. We can first look at around, we can move the light source around as if we were holding it in our hands and shining lights from different angles with it. And that's a really nice way to view these specular surfaces. Remember, it's a coin, it's going to reflect light. In this case, it's a fairly dirty silver surface. We can move the lights around and see what's going on. But the power of RTI is in this specular enhancement. And here's that specular enhancement. I can look and I can really see that there's a lot of surface damage to the object. There's scratches here. There's a very interesting dent right next to the star here. And we can zoom in on that dent and see it in a lot of detail. In fact, here's about the furthest we can zoom in on this digital file. We realize that this is the side markings of another silver coin has done this damage. So not a nice, clean, pristine specimen of a silver dollar at all. And of course, great way of evaluating this surface. We now look at normals visualization, and we can really clearly see this surface has a lot of pits and dents. It's not even close to being pristine. There's who knows what hit it there. And we can zoom out and we can see all the structures of this. So coins are one of the things that make RTI really shine, specular surfaces like this. I'm going to end the demonstrations of various RTI files with this one, which I think is particularly spectacular. RTI file of a blooming dahlia. And it's an example of a temporary object, an object that's not going to be around for very long. This flower is going to wilt and be gone in a few hours. So this is a way to document this particular species of flower and be able to show it to other people. So we can zoom in, we can look at all the details of this, but then this is just that default lighting technique. But let's move over here to specular enhancement. I'm going to change the diffuse color up because I really want to see the original color of this. I'm going to change my specularity to kind of a neutral value, and I'm going to change the highlight size to be fairly small. And I'm able to see all of the detail that's within this object. And looking around, we can look at some other areas of this flower, and it's really another outer worldly or alien kind of view of a flower, which we really haven't shown this before. And this becomes a great example of what RTI can do. Here's a normals visualization of this, and that's what the normals visualization of a dahlia flower looks like. Calibration spheres right there, by the way.